Going. All right. Remember I said, it's only these outer ones that get involved in chemistry. We really only care about the outer ones. So when we start drawing pictures of molecules, we don't care about the 2, 8, and 8 in a calcium. We only care about the 2. So Lewis diagrams, named after the scientist Lewis, who created this bonding kind of set of rules, created a simpler diagram to represent the atoms. So let's now write a little bit about Lewis diagrams. I'll do a couple practice runs. I'll leave you to your work. You can work on the sheets or the labs, whatever you need to do to get done, so you're ready to go for the weekend type thing. So now let's talk about Lewis diagrams. In a Lewis diagram, the symbol is at the center. Don't know if you remember that. We don't put the number of protons, but we use the symbol. Remember, the symbol will tell us the number of protons. That symbol identifies the element. If we really needed it, we could go to the atomic number and get the protons. So we put the symbol at the center. Just draw the valence electrons. So we just want to draw on the valence electrons. And this time, we must put them as dots. All right? We can't just do numbers because the position of them is important. So we draw them as dots. We just use, and here's a term that I didn't teach you guys. The term is the representative elements. In other words, we only use this for groups 1, 2, and then 13 to 18. So we only use this for groups 1 and 2, and then 13 to 18. Again, for the same reason that the transition metals are complicated. So we only use it for 1 and 2, and then 13 to 18. Okay? And this is a little filling rule that you'll get when I start drawing them. Fill with 4 alone first, comma, then pair up. And when I start doing examples, you'll know what I mean. Okay. There's one exception. Except helium. All right? And that's not how you spell accept. Do I need an X in there? Is that the only thing I'm missing? Except helium. Okay? This last rule is kind of the trickiest one, but I think you've done it before, and once we get going, you'll remember. Okay? All right? All right. Let's do some examples. Hydrogen. We're only doing the valence electrons, the outer electrons. I suppose I could have drew this in the middle. We draw it with an H. So therefore, we don't care about the period number, right? The period number tells us the number of orbits. We don't care about that. We only care about how many there are in the outer shell. Hydrogen, group 1, 1 dot. Right there. It means it has 1 electron in the outer shell. It can be an X, Yep, whatever you're comfortable with. Some symbol that represents an electron. It doesn't really matter what side it's on. It really doesn't matter. If I'm bonding this with something later on, I might want to put it on the side or on the bottom. Depends on where it is. But it doesn't really matter. I'm going to save helium for later. So let's jump down to beryllium. No reason. Be. How many dots will go around beryllium? Cody? What group is it in? Group 2. 2 dots. Like this. 1, 2. They don't pair up until you've got more than 4. Okay? Does it have to be at like 12 o'clock and 3 o'clock? No, it doesn't really matter. Some teachers will say, put it on the opposite side. It's going to repel it away. No, don't worry about that. We really don't know where the electrons are around the atom. We have no idea. We know that they aren't paired up, so it doesn't matter where you put them, as long as they've got two unpaired up, okay? Let's look at nitrogen. Nitrogen. N. How many dots will nitrogen get? How many dots? Nathan? What group is it in? Nitrogen. Where is nitrogen?
5.
Right here? That's nitrogen. So we're ignoring the 1. 5. It gets 5 dots. So it looks like this. 1, 2, 3, 4. Now we pair it up. 5. Okay? You okay with that? Awesome. Let's do arsenic. Arsenic. AS. Now notice, it's past calcium. But its Lewis diagram is still determined by the group number. How many dots? Yep. I picked one that was just like nitrogen. That's no fun. 5. So it's going to look just like nitrogen. So if you know that, you could go 1, 2, 3, 4, 5. Awesome. Or you could go 1, 2, 3, 4, 5. Doesn't matter which one is paired up. Let's pick iodine. Iodine. How many dots? How many dots? And let's see. Pick on Colton.
Yeah.
Paying attention?
Is
I knew he wasn't paying attention. Iodine.
it has 7 outer ring.
Sorry?
7.
7. 7 dots. 1, 2, 3, 4, 5, 6, 7. Doesn't matter which one is by itself. Doesn't matter which one. Okay? We could do this more, but I think we get the idea, right? So that group number tells me how many outer electrons there are, and therefore how many dots. We can do it for even elements beyond calcium. Again, this is complex, but even though it's complex, in the end, after that has all been done, the number of outer electrons still is determined by the group number. And you'll just have to trust me on that, because it is complex, but it is a true statement. Okay? All right? Any questions about Lewis diagrams? We're okay with that? All right, so I'm going to stop right there.